Hi everyone, this is Erez Berkner, CEO and co-founder of Lumigo. And today we're going to talk about observability, monitoring, and what should we do when things go wrong. So think about this. It's 2:32 in the morning, PagerDuty wakes you up, and DynamoDB is failing again. What do you do? And I like to call this talk, what happened when DynamoDB explodes? And I use DynamoDB, but I want to make it a bit broader. It's not just about DynamoDB. DynamoDB is different in that it is a managed service. You don't control the server, you don't control the operating system, and you're very limited with your visibility. So when we talk about DynamoDBs, when we talk about managed services, I want to broaden this to everything that is as a service. So we all know function as a service, but think about queue as a service or data as a service, Snowflake, DynamoDB, storage as a service, even Stripe, Twilio, all the SaaS services, everything that you don't control, you don't deploy agent, you don't maintain the server, you don't write the code over there, you don't define the API. All of this really creates a challenge when it comes to monitoring, debugging, troubleshooting. And that's what we're gonna focus on today. I like to call this, broader sense of managed services serverless, and it's a broad definition, but it really helps me define the core. There are no servers over here, and those applications are usually very high, very distributed, with dozens or hundreds of services that keep changing, and no longer, three-tier monolith like we used to have. So across all these services, when DynamoDB actually explodes, it's very hard to zoom out and understand the context, understand the overall application health. How does that impact without having the actual connection and context between the different services? So that would actually be the first thing we need to make sure that we have. In order to understand what's going on when something goes wrong, we first of all have to implement one way or another tracing. Because it's distributed tracing. And the point is that this tracing will allow us to go back, go upstream and understand not just that this failed, but what happened before that, where did it originate from, and what did it impact? So in this case, I can find actually what is a customer-facing API, is this business critical, and take a decision and assign a priority. Based on that, now I want to use the concept of distributed tracing and take it to the next level and be able to look at I like to call it a virtual stack trace. Like in the past, I used to see exactly which functions were called in a monolith environment. I want to be able to do the same in a distributed environment. So seeing the inputs, the outputs, the environment variables, the stack trace, the logs, everything that I can on each and every service along the path of that failure. And there are different ways to do that. One, you can use CloudWatch and other cloud native friends. I think the main point here is that you can use code and implement, in the containers, in the Lambda, before, after the managed service, different outputs, different logs that will allow you to understand what's going on. So you can log the request and you can log the payload and the output and the environment variables, and in the exception you can catch and log the exception, of course, and on the additional details. And that would actually work. The main problem is that it takes a lot of time, it requires a lot of maintenance, and you still need to connect the dots. So you need, when you have millions, it can work when you have few thousands, let's say, invocations a month. When you have millions or billions, you can no longer connect the dots via timestamps. So you can no longer see that I have one request going through in that second. You have thousands going through. And how can you differentiate the different logs from the different executions? So that becomes the problem, drilling down to the specific log groups and log stream to understand how this connects. So you have this data islands, but you're not able to connect them. But it's good for many of the cases, especially for dev and early production before you scale. It's out of the box. It's easy, relatively easy, I would say, to get started. It's supported by AWS. It's in the same cloud or cloud vendor. Um, I think the biggest challenge, it's complicated, it's time consuming to implement, it's time consuming to make sense of it. You need to really know how to configure it to get power visibility. And the biggest challenge is there's no good way to do event correlation, to trace, to understand the bigger picture. There are tools like X-Ray, for example, within AWS that allow you to do that, but they're also very limited. So they're not going across, DynamoDBs and S3 and Event Bridge and the other things that we started talking about. And therefore, it's hard to understand the business impact. What is a customer-facing API? How critical that is. The second option is to implement home-brewed solutions. So I can actually build a distributed tracing system, or better off, I can use something that is open source. And that's great because there are different frameworks for that. You might want to read, if you don't know, about Zipkin, about Jaeger, and in general about the framework of OpenTelemetry. Um, and this provides you a very nice common grounds for implementing distributed tracing and getting the information back to you in a visual way, seeing latency breakdown of the environment, getting traces. So it really, if you planning to implement distributed tracing, I suggest starting with OpenTelemetry as a first point. And if you do that, I really suggest reading this, A Consistent Approach to Track Correlation ID Through Microservices by Yan Kui. If you're not following Yan Kui, that's a great time to start doing that. If you are interested about distributed tracing, about managed services, about serverless, he is for me, the number one guy out there. And he blogs a lot. He has great workshops also to consider and books. But to our point, he is blogging a lot about correlation, tracing, distributed tracing. So this would be a very strong read for that. I think the pros for a homebrew solution, it gets as tailored as as you can possibly get because you build it, so you will have all the different perks that you want to have. It's your solution. It will be the best fitted to your needs. Um, OpenTelemetry is supported by many vendors, so that's great as a standard to use that, and then you can base future engagement based on that. And it's not cloud specific, so you can, opposed to CloudWatch, for example, so you can actually um, use it across clouds and move clouds in between. The main challenge is that you build it, so it's tailor fit, but it's very high touch. It does not solve the problem of managed services. So if you need to trace across DynamoDB, you still need to figure a way to get a correlation ID, a request ID across to the other side, across S3, across Event Bridge, across Kinesis. So it doesn't tackle managed services and components that are not supported, like API Gateway, DynamoDB, and others that we mentioned. Luckily, there are several cloud native monitoring solutions out there that were built for the modern environment to solve that problem exactly, to solve the distributed tracing and observability, monitoring, troubleshooting of the modern cloud native architectures. They're distributed, they granular, and there are multiple services over there. And what you can expect is usually those are SaaS platforms, so they get the traces to their backend and they process it to generate the view for you. So that's great in terms of maintenance. It's a SaaS. Um, it solve at the same time, by the way, it's a SaaS, so you need to be able to send information to those services. So that's also for you to know, especially around privacy and most of the vendor has like a very good policies in place for GDPR, for ISO 27001, etc. most of the vendors also solving a larger problem, not just the distributed tracing and showing you what happened, but as I mentioned, kind of building the virtual stack trace. So getting the inputs, the outputs, and everything you need to know. It's much more, and cost analysis and latency breakdown, etc. Much more than just a map of services. And usually they're using code libraries integrated in one way or another and an API using an IAM role. I think pros are, you'll find out that those tools are usually very opinionated. You come with a set of, pre-configured alerts that you should know about. That's what it means to be, niche focused. They provide more than just tracing, so many times you'll be amazed of what you can get, and you say, "Wow, I can get this," and I was just looking for tracing. And they're very low touch, very easy to get started. Usually, like a few minutes, 10 minutes, 15 minutes to get started and actually see what's going on within your environment. Uh, on the other side, this is yet another third-party platform among the many others that you probably have, and they provide more than just tracing, meaning you do get additional data. You do have, I want to say, more layers to the tools that might be great, might be even beyond what you're looking for if you're at an early stage. So just to remember that. And this is where I want to take one tool, our tool, Lumigo, and share with you how we actually do that in Lumigo. I think the main point is to see and understand what you should be aiming for. And it doesn't matter if you implement this with CloudWatch or you're using OpenTelemetry or Jaeger or using Lumigo or other tool. I want to share like what are the abilities if you do it right, or what you should expect from well observed system. So that's the main reason why I want to share how this can look like. And the main thing is that one, you're getting the monitoring, the alerts, the thing that tells you that everything okay or not and what's not okay. And then it allows you the ability to drill down and actually debug and troubleshoot to find the root cause. So let me very quickly share with you how that looks like with Lumigo. This is our dashboard. It takes literally 5 minutes and 5 clicks. No code changes required in order to get started, and you get value, you get alerts about errors that you probably never knew you have. Um, as I mentioned, the dashboard is focused on and the alerts on things that are focused on cloud native. So it's no longer about CPU or IO, etc. It's about the number of failed invocations. It's about call starts. It's about show me the biggest latency offenders I have in dozens of services that I have, because that becomes really a big problem. um, you know, runaway cost, function duration, timeout, all of these are things that you get very easy view and alerts on with cloud native tools. But at the same time, let's take a scenario when something actually goes wrong. So let's look at our issues, and we'll find an issue that is occurring, and let's suppose we'll get alert on this for Slack, for PagerDuty, but let's assume we want to dive into this. We click on this specific error that is happening, last happened 3 minutes ago. This is actually a live environment that I'm showing that is based on a cloud native architecture in AWS. And when we drill down, we can see a lot of information about that error. It's in a specific Lambda. I can see that there was a deployment over here. I can see a number of failures. And I can see that one by one, the actual failures that happen. And this is where we actually move to troubleshoot. So if we click on any of the invocation, we actually starting, I like to call it a debugging session, which is how I mentioned about the virtual stack trace. This is where you actually can start looking at the virtual stack trace. So what do we have over here? You can see this Lambda. This is why we got here. this post to social field, and you can see this event bridge. This is the service that triggered that Lambda. As I mentioned, we want to see the full transaction, the end-to-end transaction. So I'll ask Lumigo to calculate and go back and upstream and build the entire request from the very beginning all the way to the different nodes. And this is what Lumigo built over here. And this is the core of what you should be targeting. Having a direct view going from a failure, an internal failure, a DynamoDB that failed, or Lambda, or whatever, and then immediately being able to zoom in and understand, okay, this is a customer-facing API. It's an upright. I can tell you it's a business-critical API, so I need to fix it now. And at the same time, to be able to drill down and understand, okay, let's click on this. And this is the added layer that I mentioned, that I don't just get a map. I actually can click on any service and see a lot of information like the issue, the actual stack trace and the exception variables, the event that triggers the Lambda, the environment variables, the logs, everything that has to do with this invocation. These are things that are generated by the vendor, in this case Lumigo, and most of them they do not exist in AWS or in other regular tools. So in this case, details.runid cannot be an empty string. That's a failure. And if I look at the event and I click to understand what the message actually that the Lambda got, I can see that details write ID was empty to begin with. So the Lambda got an empty write ID. Just by having that visibility that you get in only in tools that are focused on cloud native applications, just by seeing that, now I know that this Lambda is not a problem. I need to understand why is this empty? Where is this coming from? So let's go upstream and let's go to the event bridge and we'll click on this. And now we can dive into the property that it got in the message, and we can see that details.runid is naturally empty also in event bridge. So we can go upstream and look at the Lambda that triggered that, and we can go one by one and check all the different services, including things like, DynamoDB, what did you try to write, what was the outcome in this case. There's a failure, the provided key element does not match a scheme, there was a retry probably, so I see the second call was successful. So it really tells you the story of what happened in each and every service along the way, all the way to things like Twilio, for example, that you can actually see, SMS was sent to this number and the response and so on. At the same time, you can also check this out in a timeline view, so to see if there are any latency issues, to see if there are any, you can see, this is taking a second. So maybe I need to dive deeper and understand what's taking the time and so on and so forth in a latency view. I want to stop over here. And again, this is just to give you the context of what you should expect from a modern distributed tracing that is focused on cloud native. To summarize, serverless and managed services in general really changes the way we develop, really changes the way we're doing things. There are many strong benefits. We didn't touch on that. A lot of accelerated development, but there are some new challenges, especially around visibility and troubleshooting of an application. We talked about three approaches to monitoring and troubleshooting, distributed services. We talked about cloud native tools. We talked about homebrewed and open source solution. We talked about third-party SaaS vendors. I think three main things that I want you to leave the session with. One is, I think you saw what you should expect in the modern environment. Don't settle for what you used to have with having logs out there in a log aggregator and that's it. You can expect more. There are better tools, better technology to serve you. Number two, think about this upfront. It's much better to bake it in during dev, during pre-prod, rather than after the fact. And third, consult. There are a lot of companies that are going through what you are going through or already have solutions. So consult with the community. There's a lot of resources, and from my experience, everybody is really happy to help. Um, and in that thought, I also want to offer my help. I really, really enjoy uh, talking with folks in our community and hearing about new project and new um, uh, application being developed. So feel free, even if you're not using Lumigo, even if it's just about managed services, distributed tracing, observability, to reach out. I'm available on this email on or direct message me on Twitter, and would love to try and do our best to help. Thank you very much, and enjoy the rest of the conference.